Oh, अश्विनी हो गया online.
Okay, so hello everyone. Today we have the expert Suresh sir that we're going to tell you details about the today's topic on voltage regulators. So carrying forward the discussion, my first question to you is, what is the basic principle and operation of the voltage regulator?
Actually, basic of principle of operation of the voltage regulator is to maintain a constant output voltage despite variation in the input voltage or the load conditions. Generally, for example, actually voltage regulators are the replacement of the battery normally we use, because as battery provide a constant voltage without any fluctuations. So similarly, the voltage regulators are the providing constant voltage. Whatever the input, it doesn't matter within the range of the input. So output remains constant. So it generally works on the feedback mechanism. Voltage regulators use a feedback loop to continuously monitor the output voltage. This feedback is compared to the reference voltage. Another parameter is the error detections. If there is a discrepancy between the actual output voltage and the reference voltage, the regulator detects this error. Another is a correction action. The regulator adjusts its internal components like the transistors in the linear regulator or switching element in the switching regulator to correct the output voltage. In the linear regulator, this involves varying in the resistance in the way that they compensate for the input variation. While in case of the switching regulator, this involves adjusting the duty cycle of the switching element. Another main parameter is the regulation. The output voltage regulation is regulated by the continuous adjustment based on the feedback loop. This ensures that the output voltage remains stable even when the input voltage or the load conditions changes. In overall, you may say that our main objective of the voltage regulator is to provide a steady voltage to the connected load, ensuring that the electronic circuits receive the correct voltage for the operation, same as in the battery. That's all.
Okay. So, my second question is, what are the main features of what are the main types of voltage regulator? How do they differ in terms of performance and application?
Okay, very nice question. The main types of the voltage regulators are categorized into two parts. Mainly, one is the linear regulator, another is the switching regulator.
Hmm.
Each type of the distinct characteristics, performance, metrics, and the application. So, on these parameters, we have divided into main two category. One is the linear regulator, another is the switching regulator. Now, first describe on the linear regulator. In case of the performance in the linear regulator, basically it is a very simplicity. Linear regulators are the straightforward to design and implement. They have fewer components and are generally easy to use. And in case of the noise, they produce less electrical noise compared to the switching regulator. which is the beneficial for the sensitive analog circuits. Means uh, linear regulator produces less noise. While we are talking about the efficiency, so their efficiency is relatively low with, with respect to the switching regulators, especially when there is a significant difference between the input and the output voltage. The excess energy is dissipated as a heat. Another parameter is the dropout voltage. In case of the linear regulators, they require higher input voltage compared to the output voltage. That is known as the dropout voltage, which limits their use in the low voltage applications. Another parameter is the low power devices. This type of the linear regulator are the ideal for the applications where power dissipation is not a major concern, major parameter, such as the battery powered devices and the low current electronics devices. Another is analog circuit. These type of linear regulator are used where low noise is critical, such as the audio equipment or precision signal processing systems.
Okay.
Now come on the switching regulators. Now when we are talking about the switching regulators, to first come on the efficiency. In the switching regulators are highly efficient, often over a 80 to 90% because they convert excessive voltage into the usable power rather than the dissipating it as heat. So this is a particularly advantageous in high power applications. Another is a complexity. Such type of regulator means switching regulators, they are more complex to design and implement due to their switching mechanism and require additional components such as inductors and capacitors. Now come on the noises. In case of the switching regulators, so they generates more electrical noise due to the switching process, which can affect the sensitive analog circuit unless proper filtering is implied in the your used circuit. Next parameter which we have to consider in the switching regulator is the high power system, suitable for the application requiring high current, significant power conversion such as the power supplies for the computer, DC to DC converter, and the battery management system. Another is the battery power devices. Such type of switching regulators are useful in case of the battery power devices to maximize efficiency and extend battery life, especially when there is a large difference between the input and the output voltage. In brief, you may say that the linear regulators are best suited for the low power, noise sensitive applications where with the very simplicity in the key. In case of the switching regulators, they are the ideal for the high power applications where efficiency and the flexibility is the input voltage conversion. So these are the basic key differences in the both switching regulator as well as the linear regulators. That's all.
Okay. So my next question is, what are the factors should be considered by selecting the voltage regulator for a specific electronic project?
Okay. So Can you repeat? What is your question? Can you explain the
No,
again?
no, what are the factors should be considered when selecting the voltage regulator for a specific electronic project?
Okay. When you are going to select a voltage regulator for an electronic project involving several factors, such as the first factor which involved is the input voltage range. It is a very important factor. For example, you are using a 7805 voltage regulator, then input range is from 12 volt to 32 volts, or even something less. You can check the data sheet. So, in case of the input voltage range is very important. It ensures the regulator can handle the input voltage range provided by your power sources. Check both the minimum and the maximum input voltage to ensure the compatibility. Another is the output voltage. When this is also very important factor. Choose a regulator that provides the required output voltage for your circuit. Suppose you are using a 12 volt circuit, then you have to use a 7812. When you are using a 5 volt circuit, then you have to select 7805 volt. Means it is very important to select the output voltage range. So you have to select accordingly. Some regulators offer fixed output while others are the adjustable output. For example, 7805, 7812, 7815, these are the fixed voltage regulator. While another is LM317, it is a adjustable voltage regulators. Means in this voltage you can change your voltage from 12 volt 1.2 volt to maximum according to data sheet variation 5 volt 12 volt and the same regulator. So it is depends on the application, which type application you are going to use. So output voltage is very important. Another is the important factor is the output current. There are various packages. For example, 7805 TO220 package carrying more than 1 ampere current, while same voltage 785, which is in the TO92 package, means like as a small transistor, it carry only 100 milliampere current. So this is the very important parameter based on your design. Ki output current should be how much. So determine the maximum current your circuit will draw and select accordingly that regulator which can provide the at least the amount of the current which needed in that particular circuit. So and with you have to take some margin too. Suppose maximum current drawn by your circuit is 1 ampere. So you have to select such a type of regulator which can provide you 1.2 ampere. Means you have some margin, right? Another is the power dissipation, and the thermal management is also very important factor. Consider the power dissipation based on the difference between input and output voltage and the current. Ensure adequate cooling or heat sink in place of the prevent overheating. Suppose a high current voltage is you are using a high current voltage and you are not using a heat sink. So in that case your regulator will be heated, so you will not be able to get the uh, actual actual current which the regulator provides. But when you use a heat sink, proper heat sink, then that maximum current you can avail from that regulators. So this is a power dissipation and the thermal management. Also, efficiency is a very great मतलब very effective factor. Depending on your project's power requirement and battery life, needs efficiency may be critical factor. Switching regulators such as buck or boost converters are generally more efficient than the linear regulators, especially when there is a significant difference between the input and the output voltage. In that case, it is very important buck and boost. Another is the another factor is the ripple and noise, right? So you have to consider such this factor also. Assess the regulator's output, ripple and noise levels, especially for the sensitive analog or RF signal where low noise is very crucial. Another factor is the load and the line regulation. Check how will the regulator maintain the output voltage despite variation in the load current and input voltage. Good regulation ensures stable performance, right? Another parameter is the package and form factor. Ensure the physical size and package type of the regulator fit your design constraints such as the PCB layout and the proper space where you can use the heat sinks, etc. So package and is very also important factor. And another major factor is the protection feature. Look for built-in protection features like overcurrent protection, thermal shutdown protection, and short circuit protection to save your circuit. When you will select these things, then your circuit and your component will not be damaged. When overcurrent, it automatically stop the voltage, output voltage. So these three parameters means overcurrent, thermal shutdown, and the short circuit protection is very important feature. Also, you cannot neglect the cost and the availability. Balance the cost of the regulator with the project's budget and ensure it's readily available in the market or it is a do, right.
Okay.
Another use of the ease of the use and design complexity is also taken to the consider. Some regulators are more straightforward to implement than the others. Consider whenever you need additional components like external capacitor or inductor. So, when you are considering these factors, it is very important to design your circuit when you consider the above mentioned the factors. So, there you have to consider these factors. That's all.
Okay.
That's all. Next question is.
So how do the regulator handle sudden change in the load input and when the design features improve their transist response? What are the design features improved for the transist response? Uh,
This is very important and very good question. So regulators actually handle sudden input voltage in load or input voltage through the various design features, right? For example, it should be able to handle sudden changes. Load transistor, which using in the regulator, when the load suddenly changes, for example, sudden increase in the current draws, or the regulator must quickly adjust its output to maintain a constant voltage. This involves rapidly responding to the change in the load current by adjusting the output power. Another parameter is the input voltage transient. If there are sudden change in the input voltage, the regulator must compensate to ensure the output voltage remains unstable. This requires the regulator to react quickly in the variation in the input power supply. Another factor is the design feature for the improved transient response. Compensation network. Most regulators have the internal compensation regulator, means internally they use the capacitor as well as the resistors that help stabilize the feedback loop. These networks are designed to improve the regulator's response to change in the load input voltage by adjusting the feedback loops, gain, and phase characteristics. Another parameter is the output capacitor is also playing an important role, right? Adding capacitors at the output helps absorb sudden changes in the load current. Suppose there is a surge, then this capacitor absorbs that the surging, providing a buffer that smooths output voltage variation. Low equivalent series resistors ESR capacitors are often used to enhance the stability and they improve the transient response. Another is parameter is input capacitance. The capacitors at the input help filters output and the smooth sudden variation in the input voltage. When you are using a capacitor in the input, when there is sudden variation in the input voltage, then it will save your regulators. So this ensures that the regulator has a stable input voltage to work with. Another parameter is the input current limit and the field fallback. Regulators often include current limiting and foldback features that prevents damage during sudden or excessive load changes. Current limiting protects the regulator by reducing the output current when the load increases suddenly, while foldback reduces the current further if the output voltage drops significantly. Another parameter is for the sudden changes, the uh, feed forward control. Some advanced regulators are feed forward control where a portion of the input voltage is directly fed into the control loop. This helps the regulator reacts more quickly to change in the input voltage, improving the transient response. Another sudden factor is the high speed error amplifiers. Using speed, high bandwidth error amplification in the control loops improves the regulator's ability to reduce quickly to transient change in the load or the input voltage. Another parameter is the inductors for the normally especially used in the switching regulators. In switching regulators, the inductor play a crucial roles in filtering and smoothing current changes. Proper selection of the and sizing of the inductor helps improve transient response by maintaining the stable current flow during the rapid load changes. And another parameter is the fast transient response design is also very important parameter to prevent the such sudden voltage input variations. Some regulators are specifically designed with the fast transient response capabilities, incorporating advanced technologies, techniques, and the components to handle rapid changes more effectively. Mean to by using these factors, regulators can maintain stable operation despite of the sudden variation in the load or the input voltage, ensuring a reliable parameter for your electronic projects or your electronic circuits. That's all. Hello, take another question.
Okay. So, our next question is, how does the efficiency of voltage regulator affect the overall power consumption of a device? It's the last question from my side. So,
Actually, the efficiency of the voltage regulator significant impact the overall power consumption of a device. For example, its efficiency, it should be very efficient. Effi- Efficiency impact higher efficiency means less power is wasted as heat and the more power is the effectively used by the load. And another is the power consumption and the heat dissipation. Power loss calculation is also very important. The power loss in the voltage regulation in the difference between the input power and the output power. This loss is typically dissipated as heat. That is the reason why we use a heat sink. When you are using a very good heat sink, then your output power will be saved and you will get appropriate its output voltage without loss. Another is the heat generation. Lower efficiency results in higher power loss and more heat. This can lead to additional cooling requirement, potentially increasing the overall power consumption. Another is a battery life in deficiency. Battery powered devices. In case of the battery powered devices, higher efficiency extend the battery life because the less power is the wasted and the more of the battery is energy goes used towards the power of the device. Another is efficiency trades off. Switching regulators, which are often more efficient than the linear regulators, are preferable in battery powered application due to their ability to handle higher power conversion with the less energy. Another parameter is overall system power consumption, which impact on the system. If in your system where multiple voltage regulators are used, the efficiency of each regulator affects the total power consumption. That is it. So regulators can contribute to significant overall power based. So power supply design, efficient regulator reduces the load on the power supply and cooling system, potentially lowering the total power consumption and the improving overall system efficiency. Another parameter is the thermal management, thermal load. Inefficient regulators generates more heat, which may require additional thermal management solution like heat sink or fans, cooling fans, which are focused towards the regulators. These additional components can increase the overall power consumption of the device. Thermal effects, excessive heat can affect the performance and the longevity of the electronics component. Right? So, we potentially leading to the further inefficient or the higher power consumption over the time. Another parameter which we have to consider is the power or cost consideration. Design choice, while high efficiency regulators might be more expensive than the low cost, so they can result in the lower total system cost due to reduced cooling and the power supply requirement. long-term saving. Investing in efficient voltage regulator can lead to the long-term saving by improving the energy efficiency and extending the lifespan of the both device and its power sources. So, in brief, you may say that efficiency of the voltage regulator directly affects the overall power consumption of the device. Higher efficiency means less power is wasted as heat, which can lead to the longer battery life, reduced high management needs, and the lower total power consumption. Conversely, lower efficiency results in the greater power loss and the heat generation, potentially increasing the overall power consumption and the cost of the device. That's all.
Okay. So thank you for the session. And I asked the audience if they have any more question, they can ask in the comment section, and we will reply after this live session. And you can always comment it out, and you can also subscribe our channel for getting more updates regarding this live session. And we will come next week with a new topic, with a new session. And for now, thanks everyone. And thanks, Suresh sir, for sharing your expertise to our audience and sharing your views on the voltage regulator. And I hope all of you have got a lots of learning from this session about the voltage regulator, how you can use the voltage regulator, and where to use, and how what are the design considerations that you have to take care when using the voltage regulator. Thank you.
Thank you.